This presentation is on calculating a t-test and interpreting the results. The t-test calculation is similar to the z-test in that given appropriate information, we plug it into the formula and generate a result. We examined the formula in the previous presentation. In this presentation, we will now apply it. Prior to this generation, however, we need to create appropriate null and alternative hypotheses. These, too, are similar to the z-test null and alternative hypotheses. You will notice as we proceed through the modules that creating null and alternative hypotheses will become a familiar process. The null hypothesis will, of course, be derived from our problem. Here it is. In a sample of 11 states in the old Confederacy, the mean per capita income for 2012, as estimated by the U.S. Census Bureau, was $37,963, with a standard deviation of $3,986. For all 50 states in the U.S., the mean per capita income for 2012 was $42,693. Do you accept or reject the null hypothesis? For our t-test problem, then, the null hypothesis is, similar to the z-test hypothesis, that nothing happened. That more directly, there is no difference between our smaller sample and a larger sample of data. Specifically, for this problem, the null hypothesis is as follows. There is no statistically significant difference in per capita income between states of the old Confederacy and the 50 U.S. states in 2012. The alternative hypothesis is simply the opposite of the null hypothesis, meaning in a crude sense that something happened. Specifically, for this problem, the alternative hypothesis is as follows. There is a statistically significant difference in per capita income between the states of the old Confederacy and the 50 U.S. states in 2012. Here is a map of the Confederate States of America, or Dixie, an important political region in U.S. politics. Its politics are generally quite conservative. Notice that the initial formation of the Confederacy included the original territory of Virginia. West Virginia seceded from Virginia in 1863. Here is the data set of per capita income for the Confederate States in 2012. The range of values is from $33,073 in Mississippi to $47,082 in Virginia. Mississippi is a rural state with low levels of education, while Virginia's northern counties are near the Washington, D.C. metropolitan area and benefit from federal and government employment, which is generally high income and demands a high level of education. This all results in pulling Virginia upward in its per capita income. Now, to calculating the t-test result. X bar equals $37,963, or the average per capita income of the Confederate States in 2012. Mu equals $42,693, or the average per capita income of the 50 U.S. states in 2012. The standard deviation, or S, of the smaller sample, the Confederate States, is $3,986. The number of cases minus 1, or n minus 1, is 10. The result of the numerator operation of $37,963 minus $42,693 is equal to minus $4,730. The denominator calculations are multi-step, with the first step being to find the square root of 10, which is 3.16, rounding to 2 decimal places. In this course, we will round to 2 decimal places with each step of the calculation. Then, $3,986 divided by 3.16 is equal to $1,261.39. We then divide minus $4,730 by $1,261.39 to arrive at the calculated result of minus 3.75. As with the z-test, we will be using the absolute value of the t-test in our interpretation of the result. So the absolute value of minus 3.75 is equal to 3.75. We now will interpret the result of the t-test. We need two items to do so: the absolute value of our calculated t-test result and the correct critical value upon which we base our decision regarding the null hypothesis. Do we reject it or accept it? Once we make a decision on the null hypothesis, we then make the opposite decision on the alternative hypothesis. We cannot both accept the null and alternative hypotheses at the same time, and we cannot reject both the null and alternative hypotheses at the same time. That would be like saying there is both no significant difference and a significant difference in the sample mean values. In other words, it would make no sense to make that claim. The critical value for the t-test works in a similar way to the z-test. The critical value tells us at what point 5% of all observations lie beyond the absolute value on the t-distribution curve. Remember that the shapes of the t-distributions vary based on sample size, with smaller samples looking less normal, with larger tails and smaller humps, while larger samples look more normal, with smaller tails and larger humps. Let's turn to page 146 in the Pollack 1 textbook. It contains the critical values for the t-test. We find the critical values based on the correct degrees of freedom for the problem at hand. What is degrees of freedom? I mentioned it in an earlier presentation. In essence, since we're working with samples and not the entire population, we acknowledge that we lack complete information about the population by subtracting one case from our smaller sample data set. For our problem, our smaller sample size is 11, the states of the old Confederacy, so we subtract one case, so 11 minus 1 equals 10. Next, we find the row of critical values associated with degrees of freedom, abbreviated as DF in the literature, equals 10. Then, we need to find the correct column of critical values under which the heading area under the normal curve. Since we need to find the point at which 5% of observations lie beyond the t-test value for n equals 11 sample size, or DF equals 10, we look under the column of 0.025 for that critical value. We find that the critical value for DF equals 10, 0.025 area under the normal curve, is 2.228. We can now make the right decision about accepting or rejecting the null hypothesis. We accept the null hypothesis and reject the alternative hypothesis if the absolute value of our calculated t-test is less than the critical value. We reject the null hypothesis and accept the alternative hypothesis if the absolute value of our calculated t-test is greater than or equal to the critical value. Since 3.75, the absolute value of the t-test, is greater than 2.228, we reject the null hypothesis and accept the alternative hypothesis. There is a statistically significant difference in per capita income between the states of the old Confederacy and the 50 U.S. states in 2012. To review, we formulate null and alternative hypotheses based on our problem and our data sets. We test the hypotheses using an appropriate inferential statistical test. The t-test is appropriate for samples of data, especially smaller samples. and the distribution of values changes based on the sample size. We conduct the test and make our decision regarding the acceptance or rejection of the null hypothesis based on comparing our calculated value to the critical value. This concludes our discussion of calculating and interpreting a t-test.